All right, so next up, I'd like to talk to you a little bit about properties of matter. Well, properties of matter have a number of different characteristics or descriptors that you can use. There are physical properties, chemical properties, as well as intensive and extensive properties. Now, your physical properties and changes are things that we're really kind of curious and interested in. An example of a property would be something that describes a substance. For instance, color of a substance, the mass, the volume, freezing and boiling point, and solubility are all examples of physical properties of a material or of matter. Now, physical changes. These do not make up the chemical composition, or they do not alter the chemical composition. They can change the size or the state. So for instance, if you have an ice cube, that can melt, so that has changed its physical state from being a solid to a liquid. That is another example of a phase transition. So boiling something is an example of a physical change. Mixing or diluting of something is also an example of a physical change. Okay. Now, chemical properties and chemical changes. Chemical properties describe whether or not a substance undergoes a chemical change. So flammability is an example of a chemical property, reactivity with acids, or inertness, which would basically be the lack of reactivity with a substance. Chemical changes result in products with different chemical composition than your reactants. So combustion, so if you were to, whenever I think of combustion, I think about gasoline being lit on fire or something that's flammable. That gasoline chemically has one state. As soon as you light it, it has another state. Corrosion, or basically the wearing away of a material, and is also an example of a chemical change. Now here is an example of kind of the process of iron and sulfur. So here would be your iron, which is Fe on the periodic table, and sulfur, which would be S2, and a mixture of these two. Okay, so if they're mixed and then heat is applied, what's going to happen is they're going to undergo a bit of a change, and they're going to change from this Fe and S2 as two separate things. They're going to make FeS, which we will see on the next slide. Okay, so, or sorry, it wasn't S2, it was just solid S. So we've got our Fe and our S, they mix together to make FeS. That's an example of a reaction of iron and sulfur. Okay, so a common misconception is that physical changes are reversible. So can you stick a rose back on a bush after you've cut it? No, you can't really. Okay, chemical changes are irreversible. Well, chapters 15 through 17 are about reversible chemical reaction. This is called equilibria or equilibrium. Now, a better thought, or a better way to visualize this and better way to think about this would be the results of a physical change have the same chemical identity, composition, formula, as the starting materials. The results of a chemical change have new chemical identity, the composition, formula, compared to the starting materials. So that's a better way to look at a physical versus a chemical change. Now, an example of a good question, or a think about sort of question, would be this. Identify the chemical change. I'm going to give you a second to think about this. Pause if you want to. Now, okay, identify the chemical change. So when we think about a chemical change, we're thinking about something like X plus Y makes XY, and I'll just leave it at XY, this one thing. These two things combine to make one thing. But in the process, the chemical composition of X and Y has changed. Okay, so I think maybe a good way to think about this is what of these answer options are similar and what are different. Okay, let's start at the bottom. D, an ice cube melts. Okay, so we were talking about an ice cube melting as a good example of a physical change. We've gone from a solid state to a liquid state. We've gone from something that's shaped like a cube, three-dimensional cube, that now is a puddle on the ground. So this would be an example of a phase change. Okay, now answer C. Kool-Aid is mixed with water. Okay, so certainly Kool-Aid has made water taste better or sweeter, but let's think about that. What's happened? So that Kool-Aid was that grain, those very small grains, and now all of a sudden, well, and we could think about jargon or terminology that we used in the previous video. We talked about homogeneous mixture. So we've made a homogeneous mixture, but what of the molecules that make up that Kool-Aid has changed? Before we answer that, let's look at answer option A. Sugar dissolves in coffee. Now those two are kind of similar to one another. We've got Kool-Aid is mixed in with water. What's that Kool-Aid doing? It's dissolving. It's making this homogeneous solution. Coffee. Sugar is dissolving in that coffee, making another homogeneous solution. So for this particular question, if A is right, then C is right as well. But before we consider that, let's think about food is digested. Okay, so when you chew up food, you've broken it down into smaller pieces. So let's go with a block. That's going to be my food. It's going to be broken down into these little pieces by your teeth. Okay, and then this little piece, it's going to go down your esophagus into your intestine, into your stomach. Yeah, your stomach, then your intestine. There we go. But within your stomach, what's going to happen to that? Well, that's going to break down in even smaller pieces. It's going to break down to super small pieces because you've got a bunch of acid in your gut, and there's a bunch of bacteria in your gut that are going to chew up all of those materials and make them even smaller. At a molecular level, it's making it even smaller. It's breaking bonds. Oh, it's breaking bonds. This is a great example of a chemical change. So A and C, those are physical changes. Those are grains of something that has dissolved. Nothing chemically has actually changed or happened to either the sugar or the Kool-Aid. All right, well, I hope this is helpful, and carry on.